Hey everyone, welcome to SFDC Stop, and in this video we are mainly going to focus on how we can find the lowest common ancestor of any two nodes given in the binary tree. Okay, so let me just construct a binary tree quickly. So this is the binary tree that we constructed in the previous video. So in the previous video we are basically talking about employees that are reporting to some other employee. Okay, and I just reversed the arrows here because we are going to construct a binary tree, and in the binary tree we have left and right childs like this. So a binary tree is represented with the arrows downwards. So let's see how we can find out the lowest common ancestor. So lowest common ancestor basically means given any two nodes, what is the common node of these two nodes who is above the hierarchy. For example, if I consider node number 5 and node number 6, then I can say that he is the lowest common ancestor, right? Because it is above the hierarchy, and this is the node which is the lowest common ancestor for 5 and 6. Similarly, let's say if I am talking about node number 4 and node number 6, then I can say 1 is the lowest common ancestor, right? So in case I talk about node number 4 and node number 6, I can say 1 is the lowest common ancestor because this is the node who is above the hierarchy, and it is at the lowest level in the binary tree. Similarly, let's say if I talk about this kind of tree, which is a very big tree. So in this case, I can say if I want to find the lowest common ancestor of this node and this node, then I can say this is the lowest common ancestor. And let's say I want to find out lowest common ancestor of this node and let's say this node, then I can say this is the lowest common ancestor again. Okay, so the thing that we need to focus on is that if both the nodes fall in the same branch, for example, let's say I want to find out the lowest common ancestor of Nelson, which is this node, and Allik, which is this node, then I can say that Allik is the lowest common ancestor itself, because it is not necessary that the lowest common ancestor is going to be above the two nodes that I'm talking about. It can be equal to one of the nodes as well. The only condition is that one of the nodes should be, either both the nodes should be below the ancestor node or one of the nodes should be the ancestor. So this can also be an ancestor, and in case we are talking about these two nodes, and if both the nodes are present below the ancestor, that is also fine. Okay, so we have to find out the lowest common ancestor. So, and one of those two nodes can also be the lowest common ancestor. Similarly, if I talk about this tree, I can also say that in case of 3 and 6, 3 is going to be the lowest common ancestor, right? Because it is in the same branch and it is one of the node. So the only thing that I want to focus here is that out of those two nodes whose lowest common ancestor we have to find, one of those nodes is also a good candidate for lowest common ancestor, and it will be a lowest common ancestor if both the nodes are present in the same branch. So in this method, if you see lowest common ancestor, it is calling another method which is also with the same name, lowest common ancestor, and we are passing on the root node here, and the rest of the things are same, object 1, object 2, and comparator, right? So object 1 is passed from here, object 2 is passed from here, and comparator class instance is passed from here. So comparator class instance will be again used to compare two nodes like we did in previous tutorials. So in case you are not aware of the comparator class, you can just understand it like a class which is having a compare method, and this compare method is going to compare two nodes like 1 and 2, and it will return true if the nodes are equal, otherwise it will return false. Okay, that's it. So let's see, this lowest common ancestor method is present here, which is going to start from the root node. So it is having a current variable. Let me just make this as well. So current will always start from the root node, which is 1 in our case. Okay, and it will have two nodes value as well, object 1 and object 2. So let's say we want to find the lowest common ancestor of 4 and 6. So object 1 is going to have value as 4 and object 2 is going to have value as 6. So I'm going to consider these two nodes as an example, and we'll see how this code is working to find out the lowest common ancestor of 4 and 6. Okay, so what we are checking first of all we are checking if the current is equal to null, return null. That means if I am traversing the left and right subtrees and I have reached a situation where the current node itself is null, that means I have null in this particular value, because this is a recursive function, right? We are going to call this function again and again. So in case I have reached a point where current node is null, that means I'm going to return null. That means I am not able to find the lowest common ancestor. So this is as simple as that. After that, we have we are comparing current.data with object 1 and current.data with object 2. That means whatever is the current node, let's say right now 1 is the current node, so I'm comparing 1 with 4 and I'm comparing 1 with 6 as well. Okay, so in case 1 is equal to 4 and 1 is equal to 6, that means if my current node is equal to any one node which is a potential candidate of lowest common ancestor as well, because I already told you that out of those two nodes whose lowest common ancestor I have to find, these two are also the potential candidates for lowest common ancestor, because it can be a lowest common ancestor if it's in the same branch, right? So I'm going to return that node because it can be a lowest common ancestor. So in case my current node's value is somehow equal to any one node, 4 or 6 or object 1 or object 2, I'm going to return that current node. Otherwise, which is not the case here because 1 is not equal to 4, 1 is not equal to 6. So we are not going to consider this if statement. I'm going to move ahead. So I'm going to find out the lowest common ancestor in the left subtree and the lowest common ancestor in the right subtree as well. So I'm calling this method again, and I'm only changing one value here, which is instead of current, I'm passing current dot left and I'm passing current dot right, and all the other values are same. So that means for this particular case, let's say this is also a case, and here we had the current value as 1 because this is a recursive call. So I need to make multiple options here. So here I'm passing object 1 as 4, object 2 as 6, and current is going to be current dot left. So let's consider this call first of all. Current is going to be current dot left. So current was 1, current dot left is 2. So current is going to be 2. So this is the recursive call. Okay. This is the recursive call. Now let's see. So after this statement, I'm going to go into this method again. Then I'm checking if current is equal to null. So current is here. This is not null. That means it's fine. I'm going to move ahead. If current dot data is equal to object 1 or object 2, is 2 equal to 4 or 6? No. Then I'm again going to call over to my left subtree. So it is again going to call over to left subtree, which is after here. Okay. So let's move on to left subtree and let's write another thing. So object 1 is again 4. Object 2 is again 6, and the current is going to have a value as 4 this time. Okay, so it is going to have value as 4, and I'm going to close this. So this is again recursive call. After that, I'm again going to check that if current is equal to null. So is my current node null? In case of 4, no, it is not null. That means I'm going to proceed forward because in this case current is 4, right? So I'm going to check if current dot data is equal to object 1 or current dot data is equal to object 2. Is 4 equal to 4? This is true because current dot data is equal to object 1. That means this condition is true. So I'm going to return current. So from here, from this particular call, I'm going to return 4. Okay. So from this call, 4 will be returned. And this 4 will be received here because I was calling in my left subtree. So 4 will be received in the left, and then I'm going to check. So before checking, I'm also going to call over to the right subtree. But if you see here, 2 doesn't have a right subtree, right? So that means when I'm going to call over to the right subtree, let me just construct this as well. So this recursive call is done because I returned back and I returned 4 from here. So now it is going to call over to the right subtree, and in this case, object 1 is going to be 4, and object 2 is going to be 6, and current is going to be current dot right, which is 2, which is right of 2, and it's going to be null. So current is going to be null. Now in this call, I'm going to check if current is equal to null, return null. So that means null will be returned from here. So null will be returned from here. Okay. So I have left as 4 and right as null. What I'm going to do? So in this particular case, I'm getting 4 from here and I'm getting null from here. And what I'm going to do, I'm going to check if left is not equal to null and right is not equal to null. That means both are not null. That is not the case. Then I'm going to move over to my else if condition and I'm going to check if left is not equal to null, return left. So both are not null. This is false because one value is null, right? Then I'm going to check if left is not null. So left is not null. This is true. I'm going to return left. So that means 4 will be returned from here. So what this recursive call means that this recursive call is also done and I'm returning 4 from here. So this means that I have found one node which is 4 from the left subtree of 1. Okay. So this 4 value will be stored in left for 1 because I called on to my left subtree. So this left is going to be 4. So I mean in this particular recursive call, because all the recursive calls are done, and in this particular call I'm going to receive a value 4. So that means 4 is present somewhere in my left subtree. Okay. Now what I need to do, I need to call over to my right subtree, right? So this is going to call over to the right subtree, and it is again be a recursive call. So let me just write everything again. So object 1 is going to be 4, which is the same. Object 2 is going to be 6, which is again the same, and current value will be current dot right. So current will be current dot right, that is right of 1, which is 3. So current is going to be 3. Okay. Then I am again going to call this recursively. So it is going to check if current is equal to null, which is false. That means it is going to compare current dot data with object 1 and current dot data with object 2. That means it is going to compare 3 with 4 and 3 with 6. Is 3 equal to 4? Is 3 equal to 6? No. That means this is also false. It is again going to call over to the left subtree and right subtree. So 3 will have a call. So 3 will have a call over to left subtree and right subtree one by one. So let's consider left subtree first of all. So while calling over to left subtree, it is going to pass current.left here. So let me just tell you here, it is also going to be recursive call. So let's consider this call 1, and I'm also going to have one more recursive call. So object 1 is 4, object 2 is 6, and current is nothing but current.left. So left of 3, which will be 5. Yeah, this will be 5. Then I'm going to check, is 5 equal to 4 or 6? So let's start from the beginning. Is 5 equal to null? No. Is 5 equal to 4 or 5 equal to 6? No. I'm going to move over to the left subtree. So it will move over to the left subtree, and from here we'll get to know that so in this case the current node will become null and it is going to return null. That means I'll return null from here. So it is going to return null, and it is again going to return null. Okay, and then 3 is going to call over to the right subtree. So 3 is going to call over to the right subtree, and in this case I'm going to pass current.right, and the current node will become 6. Okay, so in this particular recursive call the current node will become 6, and I'm going to check. First of all, I'm going to check if current is equal to null, which is not the case because my current is 6 right now, and if current.data is equal to object 1 or object 2. So is 6 equal to 4 or 6 equal to 6? This is true, 6 is equal to 6, right? So I'm going to return the current. So in this case I'm going to return 6 from here. Okay, this recursive call is done, and I'm at this recursive call. Okay, so at this recursive call I'm getting null from the left and 6 from the right. Okay, so let me just check this as well. I'm getting null from the left and 6 from the right. So what I'm going to check? I'm going to check if left is not equal to null and right is not equal to null. This is false because I'm getting left as null. Then I'm going to check, is left not equal to null? This is also false because left is null, right? Then I'm going to return right. This means 6 will be returned from here. So 6 will be returned from this node that we have already drawn. So after this, this recursive call is also done, and I'm going to come back here. So from left we are returning 4, and from right we are returning 6. And in this case left and right both have values. So I'm going to check if left is not equal to null and right is not equal to null. This is true because left is 4 and right is 6. That means I'm going to return the current node. So the current node in this particular case is nothing but 1, right? Because I'm getting something from left, something from the right, I'm going to return current, and the current value is 1, like you can see here. So 1 will be returned. So that means considering node number 4, which is this, and node number 6, which is this, 1 is the node who is the lowest common ancestor for these two nodes. Okay, so I'm getting the correct result here, that 1 is the node who is the lowest common ancestor of 4 and 6. So that's how the code is working, and I hope it is clear. So we are doing a very simple thing. Let me just go through a recap quickly. So what we are doing, we are having 4 and 6 as nodes, and I want to find the lowest common ancestor of these two nodes. So first of all, I'm checking. I have 4 and 6. Okay, so I'm checking, is 1 equal to 4 and 6? No. I'm going to call over to the left subtree. Is 2 equal to 4 and 6? No. I'm going to call over to the left subtree. Okay, is 4 equal to 4 and 6? So 4 is equal to 4. That means it is going to return 4. 4 is returned, and it is now 2 is going to call over to the right subtree, but right subtree is also null. That means it will return null. So 2 is getting 4 from left and null from right, so it is going to return 4. Okay, and now 1 is going to call over to the right subtree. So this node will check, is 3 equal to 4 and 6? No. So it is going to call over to the left subtree, and then I'm going to check, is 5 equal to 4 and 6? No. So what 5 will do? 5 will return null, because 5 is going to call over to the left and right subtree, and these both are null. So it will return null from here, null from here. Okay, null from here and null from here, and 5 is going to return null. And now 3 is going to call over to the right subtree. So we'll check, if 6 is 6 equal to 4 and 6? Yes, 6 is equal to 6. So it is going to return 6, and 3 is getting null from the left and 6 from the right. So 3 is going to return 6, because in case I'm getting non-null values from both the sides, I'm going to return the current node. Otherwise, if I'm getting non-null from left, I'm going to return left. Otherwise, I'm going to return right. So it is going to return right. And in case of 1, I'm getting non-null from left and right both. So left is going to be 4 and right is going to be 6. This condition is satisfied and current is returned. That means 1 is returned. So it is finally going to return 1, and it will say that 1 is the node who is going to be the lowest common ancestor node for node number 4 and node number 6. So that's how it's working. So let's say I want to find the lowest common ancestor of 2 and 4. Okay, so what I'm doing, I have the nodes as 2 and 4. I am starting from 1. Is 1 equal to 2 and 4? No. It is going to call over to the left. Is 2 equal to 2? Yes. So this is the node. It is going to return. Okay, so it is going to return 2, and 1 is going to call over to the right. So it will call here. Is 3 equal to 2 and 4? No. 3 will call over to the left. Is 5 equal to 2 and 4? No. So 5 will call over to the left and right. Null will be returned. and 5 is going to return null. Okay, so null will be returned from here, and 3 is going to call out to the right. So 6 is equal to 2 and 4. No, it is going to return null. And finally 3 is also going to return null. Okay, so 1 will receive 2 from the left and null from the right, so it is going to return 2. So that means 2 is the node who is the lowest common ancestor of 2 and 4. Okay, so I mean that's how it is going to be. And in this case we are also making an assumption that both the nodes are present in the subtrees, so that's why I'm keeping the 2 as an output. Okay, so this is also an assumption that both the nodes are present in the subtrees, because let's say if I want to find two employees manager and I'm giving the employee ID, so that is a I mean that is certain that both the employees are being a part of binary tree, right? So I hope this code is clear to you. Lowest common ancestor, it is just calling first of all checking for the current node, and then it is checking if current data is equal to any particular data, and then it is calling on the left and right hand side, and finally it is checking out the results. Okay, so let me just execute this code using our employee helper class. So employee helper class, in case you don't know about this is just a simple class which is having a method named as get lead manager. So in this case, I'm just constructing a hierarchy of employee records that are present in my Salesforce environment, and I'm creating a tree of employees. So I'm creating a tree something like this, a tree of employees. Okay, so all these are my employee names, and I'm creating a tree of employees. For example, Monica is also an employee, Alec is also an employee, right? So I'm going to give two employee IDs because I'm constructing a tree of employee IDs, and it will give me who is the lead manager of both employees, right? So it is going to give me who is the lead manager of both employees, and the lead manager will be nothing but the lowest common ancestor for these two employees. So in case you're just watching this video, you can just have a look at this method, that in order to find a lead manager, I'm finding the lowest common ancestor and returning that employee ID as the lead manager ID, because I'm getting the node from here, and then I'm getting the data from that node, which is going to be an employee ID, and that employee ID is returned. Okay, so let's just execute this code and let's see it in action. So I have all this binary tree constructed in my Salesforce org. So let me just execute this query first of all, which is going to give me the name and the ID of all the employees. Okay, so let me just execute this query. Okay, so right now you can see here I have the IDs of all the employees and the name of all the employees as well. And this is again a name field which I have set as an auto number so that I can quickly query employees and use those employee IDs to find out the lead manager ID. Okay, so let's check. So let's see, I have to find out the lead manager of Milana and Angela in this employee hierarchy. And if you see, Milana and Angela, they are both going to have Monica as the lead manager. Okay, so Angela is going from here and the request should go here. So Monica is going to be the lead manager of Milana and Angela. So let me just check out the employee IDs of these and we'll see if we are getting the correct result or not. So I'm going to find out the employee IDs of Milana and Angela. So this is the employee ID, or I can say name of Angela, E030. So Angela is going to have a name as E030. This is nothing but an auto number. Milana is going to have a name as E026. So it is going to be E026. And what I'm doing in this code snippet, I'm first of all querying both the employees, Angela and Milana. Then I'm constructing an instance of my employee helper class in which I have that method. And then I'm calling my get lead manager method where I'm passing Angela ID and Milana ID as well. So I'm passing the ID of both the employees, and I should get a lead manager ID, which is nothing but the lowest common ancestor of this binary tree. Okay, so that's what I'm doing. And finally, I'm querying the employee record using the lead manager ID, and I'm displaying the employee name to make sure that I'm getting the correct name. For example, for Milana and Angela, I should get Monica, right? So let me just execute this code and let's see what happens. So I have the result, and if you see here, I have the result as Monica. So if you see, focus on here, I have the result as Monica. So Monica is coming out to be the lead manager of Milana and Angela. Similarly, I can construct, I can pick up any two employees and I can see that who is the lead manager. For example, let's pick up Martin and Alice. Okay, so if you see Martin and Alice, I think Griffin should be the lead manager of both Martin and Alice. Okay, so let's see. In case of Martin and Alice, what we have, I'm just going to move over to Salesforce CLI. Martin is having E019, so it is going to be E019, and Alice is having the employee ID as E016, so it is going to be E016, and I'm going to execute this code. So if you see here, I'm getting Griffin as the lead manager for these two employees. That is, I'm getting Griffin from my result that he is the lowest common ancestor in the binary tree of employees. So if you see here as well, Alice and Martin both are having Griffin as the lead manager. So that means I'm getting the correct result. Griffin as the lead manager. So that means I'm getting the correct result. Okay. And let's see one more example as well. And this time I'm going to consider two employees that are in the same hierarchy. So let's say I'm finding out a lead manager for Nelson and Erlich. Okay. Nelson. So Erlich is having E004. Let me just add here E004. And Nelson is having E012. It is having E012. And let's see. So if you see, we are getting Erlich as the lead manager of Erlich and Nelson. And if you see here as well, if I'm considering Nelson and I'm considering Erlich, then Erlich is the lead manager of Erlich and Nelson because he is the lowest common ancestor of both these nodes, right? I already told you that the node can itself be the lead manager or the lowest common ancestor. So Erlich is the lead manager of Erlich and Nelson. And I'm just going to consider one last example, and this time it's a big one. Let's consider Milana and Martin. So these are the two ends of a binary tree. And if we see, Richard should be the lead manager of Milana and Martin. Okay, so let me just check it quickly. So let's see, Salesforce CLI. So Milana is having E026. So I'm going to write here E026. And Martin is having the ID as E019. So I'm going to write here E019 and let's see. So I'm going to execute this code and we have the result and we have Richard as the lead manager. Okay, so we are getting the correct result again. Richard is the lead manager of these two employees. Okay, so I hope this concept is clear to you, that how we are finding out the lowest common ancestor inside the binary tree and how we are also finding out the lead manager for any two employees that are present in the binary tree. So in case you are coming from the previous videos, that's well and good, because we have just solved a real world problem using binary trees by forming a hierarchy of employees, and we are able to find out the lead manager for any two employees in that particular hierarchy. Okay, and that's all for this tutorial, everyone. I hope you learned something new, and I hope you understood that how we can find out the lead manager using any two employee IDs that we have. And I'll see you in the next tutorial, and yeah, let me know your feedback in the comments down below, and I'll share all the code snippets and everything in the video description. And in case you want to visit the blog, you will have the link to this blog in the video description as well, where I have all the code and I have explained everything. Okay, and in case you just want to have a look at the code, you will have the GitHub repository link in the video description and in the blog as well, that you can refer. And yeah, I'll see you in the next video. Till then, have a good day. Bye bye.